In addition to looking at our trained model attributes, we can also use those to deploy a PCA model and use it to make predictions. To deploy a trained model, we simply call that model by name and call deploy. Then we pass in a few details about the instance count, 1, and instance type, which I'm using a T2 medium, for the endpoint. When I run this code, I can see that two things are automatically created. First, a model with some name, and an endpoint with some name. Now for built-in models, these two are often automatically created together, but for some custom models, as we'll see later, we'll have to separately create a model and then create an endpoint. You could also consider using a different, more powerful instance type, but a T2 medium is going to be fine for our purposes. This will take a few minutes to deploy, but once it does, we can then use it, applying it to our training data and transforming it into PCA components. In SageMaker, you've seen that an endpoint can be made accessible via a web app by attaching it to API Gateway. But in this case, we're just going to want to use this predictor to process our original training data and create dimensionality reduced data. Now that this predictor is deployed, I can use it to modify our original training data. To apply an endpoint to some data, I just have to call .predict and pass in our training data. This function is going to, by default, expect a NumPy array as input, and so I'm passing in the data that we converted before. If you recall, this was just our scaled, normalized, and cleaned data frame converted into a NumPy array. So this predict function is going to look at the features of every data point in this set and convert them into PCA components. So this will hold the PCA component values for each of our original 3,000 or so training points. Let's take a look at the first data point by printing it out by index 0. So this is data for just one of our counties. I can see a key projection and a float32 tensor. This holds our 33 component values. As with the rest of our analyses, the top components are actually going to be at the bottom of this list here. Now, using these names and this information about ordering, I want you to create a transformed data frame. Specifically, I want you to complete the function createTransformedDF. This will take in a list of our PCA training data that we just generated, our original county scale data frame, and a number of top components. I want you to create a data frame that's still indexed by state county, but each column corresponds to one of these top n components. So if this is 7 top components, you'll have 7 columns of data. Your resultant data frame should look something like this. This function essentially creates a data set where each county is described by the top n principal components, and it's exactly what we'll need to move on to k-means clustering. So try to complete this function, and if you do, you can move on to the next steps, which are deleting the PCA model endpoint that we're done using, and moving on to training a k-means model on this new transformed data.